All right, in the last video we talked about solving absolute value equations, and we talked about how absolute value means the distance away from zero on the number line. And in this one we're going to be talking about absolute value inequalities. So we still need to understand that idea that absolute value is a distance, right? But I want to talk a little bit about these symbols and kind of give you a way to help you remember how you're going to be solving these. So remember before when we talked about the and statements and the or statement. So if it's an and statement, we want the intersection, and that was what they have in common or their overlap. And the or statements is the union, which means all of the elements in both sets. Okay? And so those are going to come into play again on these absolute value inequalities. So when your equation, once you get your absolute value isolated, then you're going to look at the sign, the inequality sign that's in there, and that's going to help you know whether you're looking for the intersection or the union. And so here's just a little way to help you remember. So remember these are the less than and equal to signs, and I tell students to kind of remember it because it looks like a little squished L. So you can remember that's the less than, that's the way the less than goes. But on these, I want you to think about it as less than. Right? Just a little silly way to help you remember that when it starts off like this, right? When you get your absolute value by itself and you look at what symbol is there, if it's one of these two, it's an and statement, so we're looking for the intersection. But if you have one of these two, right, a greater than or equal to, then I want you to think of this as greater. All right, so those are going to be or statements, and that's when you want the union or the elements, all of the elements in both sets. All right, so let's take a look at an example of one that you might need to know how to solve. So if you're asked to solve this, you're going to be asked to solve, and then after that, you're going to graph it on a number line. And then I also want you to write the answer in interval notation. Right? And so if I have this, I've got the absolute value of 9x minus 1 is less than 6. So first thing I'm going to do is look and see what my symbol is. So my absolute value is already by itself. And so I'm saying all of this absolute value has to be less than 6, right? And so this is going to be an and statement because it's a less than, right? So I'm going to put that down here so you remember. All right, and then remember that at this point you're going to write your two different equations out, right? On this side, it's going to just be like what we have without the absolute value. So 9x minus 1 is less than 6, right? But on this other statement that we're going to write, let's leave the left side alone. So it's 9x minus 1, but we're going to be changing this to a negative 6. And since we're changing that to a negative, we also need to flip that inequality sign there. All right, and you can kind of think of it as when we multiplied or divide by negative numbers, that inequality sign flips, right? So make sure you remember, flip the inequality, change the sign of that number. And then from there, you're going to solve it down just like we did in the earlier sections of this. So let's start by adding 1 over, because we're trying to isolate x on this. So that gives me 9x is less than 7. And then it's connected by multiplication there, so let's divide both sides by 9. So x is less than 7/9. All right, and then on this one, we've got to add 1 over. When we do that, we're left with 9x on the left side and negative 5 on the right side. and it's connected by multiplication, so let's divide both sides by 9. So x is greater than negative 5/9. All right, so we did the first part, we solved it. Now we need to graph it. So let's make a little lovely number line over here. All right, here's 0. And then one of my numbers is negative, and one of them's positive. So I know my negative 5/9 is going to be somewhere over here. And my 7/9 will be over here. All right. And now, let's try these. Get at this. So I want to graph both of these on the same grid. Or on the same number line. So I have x is less than 7/9. So at 7/9, I have an open circle because it doesn't have the equal to part. It's just less than, so it doesn't include it. But it's everything less than it, or all of the stuff to the left. Right? And then we also have x is greater than negative 5/9. So again, it's an open circle there. And then everything greater than 5/9, or everything to the right of 5/9, right? And then we're thinking about this going, okay, this is an and statement, right? So I want to know the intersection, or where do they overlap, is what I'm looking at here. So my overlap looks like it's going to be, right, all of this stuff between negative 5/9 and 7/9. And so to write that in interval notation, you'll do negative 5/9, comma 7/9. That tells us we want all the stuff that's just in between. Right? And when you graph this on the computer, make sure that you're only graphing that part that I have shaded in the orange there. We don't want those other parts because we want to graph on there the parts that they have in common. So do this on your paper, but when you put in your answer on the graph, it's just the stuff in between. Okay? All right, let's try one more. And so with this one, again, the same directions, right? Solve, graph, and then make sure you write your answer in interval notation. Okay. So this time I've got x plus 12 all divided by 6. And notice that this is all inside absolute value this time. So that looks a little different, right? But we're still just going to take the same idea that we've been doing with all of these and apply it to this. So we have this is greater than 1. Okay, so first off, I'm going to start off thinking about, okay, what symbol do I have? I have a greater, all right? So I know that this is going to be an or statement. And that means I want the union, all elements in both sets. Okay, my absolute value is already by itself, so that's the point in which I can write out my two different statements. All right, so my first statement is x plus 12 over all divided by 6 is greater than 1. All right, and then I'm going to put this or in red to make sure it stands out. Or, because this is going to be an or statement. All right, x plus 12 divided by 6 is less than negative 1. All right, so we had to flip the inequality, change that number to its opposite. Okay, so now let's solve these down. And this is where some people get a little bit confused, like, how do I solve this? Something like this. So if I'm looking at this, I'm thinking, okay, this whole thing is divided by 6. And so in order for me to try and get x by itself, I first have to undo this dividing by 6. So the opposite, or the way to undo dividing by 6, is to multiply by 6. So I'm going to multiply by 6 on this side and also on this side. All right, on this side, those 6's divide out, right? We did that on purpose so we could get rid of it there. And then we're left with x plus 12 is greater than 6. And now let's subtract the 12 over so we can get x by itself. So x is greater than negative 6. All right, so there's one of our inequality statements. Let's do the other one now. And again, just like we did over here, right, we're going to first multiply both sides by 6 so we can get rid of that denominator there. And when I do that, right, I'm going to be left with x plus 12 is less than negative 6. Okay. Now at this point, if I would have multiplied both sides by a negative, I would have to flip that inequality sign. But I don't need to flip it because the number I was multiplying by, right, was a positive number. So just watch that closely. All right, then let's subtract the 12 over. So x is less than negative 18. All right, I've got my two inequality statements there. So now let's graph these both on number lines. So I've got negative 18 and then negative 6, right? And 0 somewhere down there. Okay, so let's start with this one. So if we have x is greater than negative 6, so I'm going to have an open circle at negative 6 because it doesn't include it, right? And then I want all the stuff greater than it, so all the stuff to the right. And then on my other one, I have x is less than negative 18. So at 18, I have an open circle there because it doesn't include it, doesn't have the equal to part, and then all the stuff to the left. Right? And then this is an or statement. So we want everything that is, everywhere we see the graph, where the red graph is, where the green graph is, right? All of those for both sets. And so this means we're going to have a little statement that has a union in between it because we have part of the graph that's missing. These numbers between negative 18 and negative 6 don't work for this inequality statement, but every other number on the number line would work. It's just these few in the middle that don't. All right, so to write down what we're saying that inequality is, it would be negative infinity to negative 18, parenthesis, because it doesn't include it, union, negative 6 to positive infinity. All right, and make sure on this negative infinity you remember to write that negative in your answer. All right, sometimes it's easy to forget about that, but if it's headed in the negative direction, then it's going towards negative infinity. All right.